I will start from a quote from Albert Einstein. He said, "An intelligent fool can make things bigger and more complex, but it takes a lot of courage to move in the opposite direction." We take this concept very seriously here at Rival. Any conventional factory is still based on the model of the conveyor belt from the 1950s of Henry Ford. The product goes through all the stations in a serial way. If you want to produce multiple products in the same place, in a serial system you cannot do that because the full system is specifically designed to produce one product, one vehicle. We are revolutionizing all of this. The Microfactory fixes all these problems.
I'm Mike. I lead Arrival Automotive. A typical automotive assembly plant will cover millions of square feet. Because you have to invest so much money to set up the factory, you then have to produce hundreds of thousands of vehicles. You're way overproducing for that local region. Our microfactories cover a couple of 100,000 square feet. Our van microfactory, for instance, is sized to build 10,000 vans a year when we're operating on 2 shifts. And at that size, we believe a metro area can support almost all of that demand. We're doing things nobody else has done before, and it takes a very unique mix of talents that bring that to life.
Hi, this is Napo. I'm the Chief of Mobile Robotics here at Rival. The Microfactory is basically built around 2 main components. The robotic cell, which is the factory inside the factory. Think about it as a cluster of robotic arms. It's completely driven by computer vision and several forms of AI-based control. And then you have the glue connecting all the elements inside the factory, all the cells. This technology is mobile robotics. So robots that move in the environment autonomously, robots that interact with the cells and with any other robotic factory. We are reactive. We are adaptable, we are reconfigurable. This is the DNA of the Microfactory.
The cell architecture is really exciting and it's really unique. My name is Raj Vyas. My role is to develop the assembly processes which allow us to build these microfactories. We're developing these microfactory cells, on average 20 meters by 20 meters, and those cells allow us to build a huge number of different products. That gives us scalability, modularity, and automation.
We aren't really a vehicle manufacturing company, and I say that because if you look at the people in the company, half of them are software engineers. So we are, at our heart, a tech company. And I can tell you that's dramatically different than a traditional vehicle manufacturer. One of the great enablers of the microfactory approach is keeping the capital, the investment in the microfactory relatively low, because that's what allows us to build many of them. And so in the case of robots, we are buying very standard robots that several different companies produce. What we're developing inside the company is very sophisticated software.
In robotics, semantics is the study of understanding. How does the robot calculate its location in the space inside the microfactory? By developing AI tools to calculate all these features of semantics, we build systems that are capable of interacting. This is extremely powerful because we are basically moving from what I would call the glorified automation to advanced robotics on the shop floor. It's a key feature of the Microfactory.
Our software team, they're developing advanced vision systems. Our goal is to put those vision systems on these robots. So the robot will go into a particular location, pick up certain parts, and identify where those parts are using advanced sensors. Once they've identified those parts, pick those parts up and locate them into position.
We're supporting this idea of local manufacturing, and we're part of a community. We're not only creating jobs, we're paying taxes. We really see this idea of distributed manufacturing as a much more beneficial model to the communities where we're located than the more traditional approach.
The microfactory concept is phenomenal. The product is made here, it stays locally, and it's electric, That helps our air quality and it helps our citizens. My name is David Swenson. I'm the Director for Economic Development in York County, South Carolina. The economic impact, can't say enough about the investment that's being made, the fiscal impact that has in our community, the social impact of what it will do to bring jobs, and the interaction our community will have with a cutting-edge technology company making electric vehicles is exciting.
Our vision is, over time, hundreds of microfactories scattered all over the world. It's not a question about are there even more opportunities, it's which opportunities do we want to explore first. We're using microfactories and the microfactory approach to produce vehicles, but I don't see any reason why this same idea can't be applied to other manufactured goods. The most profound technologies are the ones that become interwoven into the way that you live your life and the way that the society operates. And eventually they become such an integral part of the way things are done that you forget they're there. They just become the way that things are done. And I think what Arrival is developing could well be technologies along those lines.